Okay, in this question we've got heights of adult male elephants. We're told they're normally distributed. Okay, and we've got a sample of 12 heights, and we've got to do, a 98% confidence interval. So we already had normals on this paper, so confidence intervals are the other situation where you may be interested in a normal distribution. So for a confidence interval, there's a recipe, which is a value plus or minus another thing times something over something. Look up this recipe in your notes if you've forgotten it. But there are 4 things you need for this. You need an X bar, you need a sigma, you need an N, and you need a Z. Now, 3 out of the 4, the first 3 should just be maybe doing some calculations. You're going to have to get X bar by doing these data on your calculator and getting that from your calculator. Okay. For your standard deviation, you don't use your calculator because, look, they tell you the standard deviation here. Watch out for that. Okay, and then we need an N, which is just how many elephants in the sample. That should be easy. But your Z, you have to do a picture. And for a confidence interval, the picture always looks like this. The percentage confidence, that 98%, is always the area in the middle. So you have to work out how much area is hanging off each end. Okay, and because your calculator on inverse normal likes the probability to the left, okay, you're probably best off using this probability here, probability of that end, and of course this will give you the negative Z value. Okay, you want both, you want the positive and the negative one. The one to record is probably you write down the Z value without the minus for these 4 here, and then you slot them into the recipe, and you get one value when you use a minus and another value when you use the plus, and you state that clearly in nice square brackets. You give these to lots of decimal places, sometimes more than 3 significant figures is sensible, and you're not going to get penalized for giving too many places of decimals here. Then we've got to, we are told that the mean height of adult male Asian in bold, was it Asian before? No, it was African before, is known to be 2.90 meters. So we've got a different kind of elephant with this mean height, and we need to use your confidence interval to state what can be concluded about the mean heights of adult males in these 2 types of elephant. So either 2.90 is going to be within your confidence interval, in which case it's quite plausible that the 2 kinds of elephants have got the same mean, because remember the confidence interval is a region in which we're fairly sure, 98% sure, the mean will lie. Okay, but if 2.90 is less than the smaller number or greater than the bigger number, then that means we've got a pretty firm conclusion we can draw that the mean for Asian elephants, okay, is either smaller or greater than the mean for African elephants. So depending on whether the value here is in your confidence interval, and if it isn't, on which side it's there are different kinds of conclusions you can draw here. Okay, so if it's in the confidence interval, you can't draw a firm conclusion about which type of elephant is bigger. But if it isn't in the confidence interval, then look which side it's on, and then you should be able to say without complete certainty. It's only in statistics we only ever have evidence for something, but you'll say that there's some evidence that the mean for Asian elephants is more or less than it was for African elephants. Hope that helps.